All right. Hello, everyone. It's Mr. Widmeyer. I am coming to you pre-recorded in preparation for my absence today, Friday. I'm in Ohio right now, and I wanted to make sure you guys still learned something while I was gone. So here we go. All right, before I get started, I need you guys to do a couple things first. So you're going to want a piece of paper. So go ahead and get out a piece of paper. You're also going to want to go up to the front of the room and grab one of those red mirrors that we used on Wednesday, because we're going to be doing reflections today. And you're also going to want to grab a piece of patty paper. Okay, it's a square sheet of wax paper. It's in a little green box. Okay, it's called patty paper because it's the paper that goes between hamburger patties when they kind of stack the hamburger patties together. Okay, so if you want to go ahead and pause the video while you get those things, and then you can play it again once everyone's kind of got those items. Okay? So hopefully you've had a chance then to go ahead and grab those things, and I'm going to go ahead and get started as if everyone's already got it. So again, pause the video if you still need time to collect the things together. Otherwise, you need a piece of paper, you need the mirror, you need a piece of patty paper as well. The notes that the substitute passed out we're going to use in a little bit, but you need your own sheet of paper for right now. So, okay, here we go. Okay, so we're talking about reflections today. Okay. So reflections are one of the transformations we're going to be responsible for knowing. Okay. You may have understood a reflection to be a flip back when you were in elementary school. All right, but we're going to start using the word reflection because we're in high school now and we don't want to use those little one-syllable words. We want something that sounds more complex than that. So a reflection, okay, if we define it, it is a rigid transformation. Okay, now the word rigid, right, means that it doesn't change, okay, or not immovable kind of thing, okay, it's fixed, right? And so a rigid transformation, that just means that the shape that's being reflected or the object that's being reflected does not change its shape or its size. It stays the same shape, it stays the same size. It stays rigid, okay, as it's transforming. So a reflection is a rigid transformation that moves points by flipping them, okay, over a line called the line of reflection. Okay, so a reflection is a rigid transformation that moves points by flipping them over a line called the line of reflection. Sometimes, okay, when we talk about symmetry on Wednesday, you can also think of it kind of like as a line of symmetry for the two objects. Okay, that's kind of a related idea. Okay, so what I would like you guys to do, okay, once you kind of got that definition written down here, is we're going to do a little example. I'm going to show you two different tools that we kind of have at our disposal to help us do reflections kind of in a plane, not on the coordinate plane. We're going to look at that in a little bit here, as you can tell from your notes paper that the substitute passed out. But we're going to do a reflection just in the plain old two-dimensional plane right here. So what I want you to do is go ahead and use a straight edge, draw a line. Okay, if you don't have a straight edge, just use your mirror. Mirrors are really good tools for drawing a straight line. Okay? Once you've got your straight line, then go ahead and on this side of, this is going to be our line of reflection that we're going to use, and on this side of that line of reflection, let's go ahead and draw some sort of quadrilateral. So I don't know, something like this, and then like that, and then this, and then something like that. Okay, doesn't have to be perfect, doesn't have to be identical to mine, just some sort of quadrilateral, just so we kind of get an idea. And let's go ahead and label these points A, B, C, and D. Okay, and so we want to reflect this shape, this object, over the over this line of reflection here. Okay, so now one option we have is to take our patty paper here. Okay, so once you've kind of got that shape drawn, is we're going to take our patty paper, and you can see that the patty paper is nice because it's very transparent. In fact, you can see from the projector there, it's almost, it's hard, it's pretty much you can see as if, you're looking right through it, okay? And what we're going to do is, using our patty paper, and I like to kind of like put it up against the edge here so that way I can use it again potentially. I'm going to kind of draw end points at the end of my line of reflection there, and then I'm going to kind of copy that line of reflection, or trace it I should say, using my patty paper. And then I'm also going to trace, without moving my patty paper, I'm going to trace points A, B, C, and D. Okay, if you want you can label them. Okay, like so. So now if I move my paper, you can kind of see them separate, right, from the rest of the actual original shape. Okay. Then, to show the reflection here, what we're going to do is we're going to take our patty paper and we're going to flip it over, okay, just like the kind of definition that we have there, all right, of the reflection, and we're going to line our line of reflection back up so that the kind of end points match up, okay. And you can see now that we have these reflected shape, or reflected points, I should say, of our original shape over here on the right. But the problem is, they're not actually on the paper where we want them. Well, if you draw on the back of the points with your pencil or pen, pencil's best, by the way, for this, okay, and when you move the paper away, you can see the points lightly have transferred. And so we can go ahead and darken those in. Okay? Now, since these points are a reflection of their originals, right, we should name them that way. So, for example, this point right here is a reflection of A, so we're going to call it A prime, right? This point here is a reflection of D, so it's D prime, reflection of B, so B prime, and then C prime is right there. Okay, and we'll go ahead and then connect the dots here to complete our shape. So, okay, and one more. There it is. Okay, so there's our reflected shape. Now, as you can see, or hopefully here that you can see, we have our original shape and its image. Okay, has the image changed its size or shape from the original? And if you look at it, the answer is no, right? We already said before that a reflection is a rigid transformation. That means that the original shapes, when it's reflected, will not change size or shape, okay? The orientation of it changed a little bit, whereas AB was kind of on the right and DC was on the left. Now A prime, B prime is on the left and D prime, C prime is on the right. That's the nature of the reflection there, okay? Also, if we were to kind of connect A and A prime using a segment, and for example B and B prime. So for example, we're just going to draw some segments in here that connect the original point to its image. Okay, you'll notice something here. This segment from A to A prime, how does it look like it relates to this line of reflection? What kind of angle does it look like it creates here? And if you think right angle, you're right. Okay, that's true in general. Okay, the segment that joins a point and its image under a reflection, okay, that segment is perpendicular to the line of reflection, and the line of reflection also bisects it. So that creates two little congruent segments right there. And then same thing with B and B prime. It's at a right angle, and then those two parts are congruent, which kind of makes sense, right? B is one distance, is some distance away from the line of reflection. And so then for its reflection must also be that same distance away in the exact opposite direction. And we'll utilize that later when we talk about coordinates and stuff. Okay? So again, the segment here between the original point and its image, okay, is at a right angle to the line of reflection, and it is bisected by the line of reflection. This segment is bisected. So the distance from A to the line of reflection is the same as the distance from the line of reflection to A prime. Okay, and that's going to be true in general for D and D prime, for C and C prime as well. Okay, so there's that. That's one way we're going to utilize. Okay, now we're going to do another shape here. And let's do a triangle this time. So draw another line of reflection. Okay, I'm going to draw mine kind of diagonally like that. And I'm going to draw a little triangle here. Let's try and make a nice right triangle. Let's see if I can do a right triangle, or a relatively right triangle. Okay. Very good. And we'll call this triangle ABC. And I'm going to put a little right angle in there, even though I'm not sure it's a right angle, but we're going to call it a right angle. Okay, and then now take your mirrors out. And you're going to want to take your mirror, make sure that you're using the beveled edge down and facing you. Okay, the beveled edge should be down and facing you. And you're going to need to turn your paper so that the original shape is facing you, and the mirror is going to go right on top of that line of reflection. The beveled edge should just go right over it. Okay? Now you can't see here through the projector, but there's a reflection I can see through my mirror. We've already kind of done this when we were like moving the hat around on that, that for the girl or whatever in the one worksheet. Okay, Elizabeth, I'm sorry if this hurts your eyes, and Michael, I'm sorry if this hurts your eyes too. Okay, if you don't want to do this one, you don't have to. Okay, you can skip it and just do the patty paper again. But when you see the reflection of triangle ABC, go ahead and don't worry about trying to draw the whole shape. Just go ahead and just copy down the vertices. Okay, we can use the straight edge to fill it, to kind of connect the dots there. We're just worried about trying to get those vertices. And so now that I've gotten the vertices drawn in, I'll go ahead and use my red pen, which I would not have been able to see if I was using my mirror there. And we'll kind of connect those dots. Okay, and so now we'll turn our paper back the right direction. And again, we'll rename these points B prime, C prime, and A prime, since these are all the transformed, reflected versions of their original or pre-image points. Okay? And again, the same situation is true here. If we draw, a segment connecting A to A prime, then certainly that's at a right angle, and this segment part is congruent to that segment part. Okay, the distance of the image to the line of reflection and the distance of the original or pre-image to the line of reflection is always going to be the same. Okay, so the line of reflection bisects the segment that joins the image and the original point. Okay, so just to summarize that, the segment that contains a point that is the pre-image or original, whichever words you want to use there, okay, and its reflection. So the segment that contains a point, the pre-image, and its reflection, okay, which is the image, okay, is perpendicular, right, at a right angle to, and equidistant to the line of reflection. Okay, equidistant, right, that just means equal distance. It's equal distance. A is equidistant to the line of reflection as A prime is equidistant to the line of reflection. The distance from A to the line of reflection is, I should say, this. The distance from A to the line of reflection is the same as the distance of the line of reflection to A prime. Okay? So there's that. That's two ways to do a reflection by hand using the tools we have available to us, a mirror or a piece of patty paper. Okay, and these are tools that we can use even when we go to the coordinate plane. So speaking of coordinates, let's go on to the coordinate plane. All right. Oh, by the way, any questions for me? Good, because I can't see your hands. I'm not here right now. I just sound like I'm here right now, but I'm really not here. Okay? It's just a computer. I'm laughing right now, in Ohio, though, at the idea that you raised your hands, maybe. Okay, reflections in the coordinate plane. Okay, so we are going to reflections in the coordinate plane. I don't know why I capitalized P but lowercase c there. I'll try and fix that in editing. Okay, so we're going to do some transformations here. Let's do some line reflection examples. Okay, so example 1 here. Okay, so we're going to reflect A that has coordinates -3, 2 over the x-axis. Okay, now we could write that sentence, but also we can do it symbolically. Okay, we can just write a kind of an R and then put a little x-axis. So this stands for reflection over the x-axis, and we can put our point right there, -3, 2. Okay, so that's another way to write this as well. Maybe I'll put that in parentheses there. So, or we could say this. We can either, write out the words, reflect point A that has coordinates -3, 2 over the x-axis, or we can use this. R stands for reflection, x-axis over the x-axis, and then -3, 2 is our point they're going to reflect. Okay, so let's first of all graph A, which has points -3, 2, coordinate -3, 2. So -3, 2. There's A. And we want to reflect that over the x-axis. Now let's see here. X-axis, that's this guy right here, right? Okay, so let's see here. That's our line of reflection. Where is A going to end up? Okay, right now it is 1, 2 units away from the x-axis. So in order to reflect it, it's got to go 1, 2 units down, and so A prime will be right there. So A prime has coordinates, still -3, but now -2 is the y coordinate. Okay. Number 2 here. Let's now, and I'm going to use the kind of shorthand notation here. Let's reflect over the y-axis point B. Okay, and B has coordinates 4, -1. Okay, so we're going to reflect over the y-axis point B that has coordinates 4, -1. So this is like for B. Okay, and so then B prime, well, its coordinates B. That's what we want to try and figure out here. So again, we'll plot. B has coordinates 4, -1. So 1, 2, 3, 4, down 1. There's B. Okay, and so our line of reflection in this case is the line Y, or the y-axis. Okay, so here's B over here, here's the y-axis. So right now try and think about where will B end up? Where will B reflect to? Okay, B is going to reflect over the y-axis over here. And how many units away from the y-axis is point B? Well, let's see here. 1, 2, 3, 4 units away. So it's going to go 1, 2, 3, 4 units in the other direction as well. And there's where we put point B prime. That has coordinates -4, -1. Okay, and the last point we're going to reflect here is point C. We're going to reflect over the line y equals x. Okay, the diagonal line y equals x, the graph of line y equals x, right? What is the slope here? The slope in front of this, x is a 1, right, or 1 over 1, and the y-intercept is 0. So it's the line that goes through 0 and has a slope of up 1, right 1, up 1, right 1. So it's just kind of like diagonal line. Okay, and we're going to reflect the coordinates of point C, which is 1, 3. And so then we want to figure out what is C prime going to be. Okay, so I'll go ahead and plot point C. So 1, 1, 2, 3, there's point C. Okay, and for our help here, I'm going to draw in using a pencil. I'm going to draw in the line y equals x to kind of help us out some. So I think it'll be beneficial to have that for us. Okay, so there's line y equals x. I didn't do a very good job down here, but you get the idea. Okay, so let's see here. It looks like C is basically like a diagonal one diagonal of the block away, so we're going to go one diagonal the other direction, and there's C prime, which has coordinates 3, 1. Okay? Now if you look here, there's kind of a pattern to how these reflections end up. Okay? Notice here when we reflected over the x-axis, A, what changed to A prime? The x-coordinate stayed the same, but the y-coordinate is opposite. When we reflected over the y-axis, what changed in point B? Here was the original 4, -1, and it changed to -4, -1. So what changed? The x-coordinate was the opposite. And then for the line y equals x, what changed here? We had 1, 3, and then what it changed to? 3, 1. Okay, so we have some general rules here. Rules for line reflections. Okay? So for a reflection over the x-axis, okay, we take our original point xy, and it changes. Well, for the x-axis, what happened? The x-coordinate stayed the same, so our x-coordinate will stay the same, and the y-coordinate is opposite, and we'll denote that by putting a negative in front of the y. If y is negative, then this will become positive. If y is positive, then this will become negative. Okay? And as an example, we can say, for example, the point -3, 5, if that's A, will become A prime. It'll stay -3, but go to -5. Okay? So there's kind of our rule that we can use there. If we're reflecting over the x-axis, here's kind of the general summary we can do. You can also eyeball it if you have the graph there available to you. But if you don't have the graph available, if you just have the coordinates, then this is also helpful to have, to be able to change those coordinates. Okay, for a reflection over the y-axis, we're going to take our point xy. And again, let's go back to what changed up here. The coordinates 4, -1 changed to -4, -1. So what changed? The y-coordinate stayed the same this time. The x is the opposite, so -x. And as an example for that, we'll have the point B, which has coordinates 5, -1, and it becomes B prime with coordinates -5, -1. Okay, the x-coordinate is opposite of the original. The y-coordinate stays the same. Okay, and lastly then, for a reflection over the line y equals x, okay, we're going to take the point xy, and we're going to flip the y and x coordinates. Which kind of makes sense here. What are we reflecting over? The line y equals x, so the y's and x's switch. And so as an example of that, we can take point C that has coordinates -3, 2, and it will become C prime with coordinates 2, -3. Okay, these points are obviously different than the points we graphed up here. All right, so I'm going to give you guys here something to try. So practice. Use the rules to find the image under each reflection. Okay, so those are our directions, and I'll give you 4 here. So 1, I'm going to have you reflect across the y-axis the point 3, -4. Okay, what does that become? 2, I want you to reflect over the x-axis the point -1, -2. What does that become? And then 3, I want you to reflect over y equals x, the point -5, 6. And what does that become? You go ahead and pause the video here. Give yourselves like a minute to do this. And I'm going to go ahead and answer it then. Okay? So once you're ready, go ahead and start the video, and then I'll answer it. So you should have gotten -3, -4, -1, 2, and 6, negative 5 for your answers there. Okay, using again our rules that we have up here. Okay? All right, let's flip our papers over here. Now, we don't always have to reflect over horizontal line, like the horizontal line, or sorry, the x-axis or the y-axis, or the line y equals x. We can reflect over other vertical or horizontal lines. Okay, so for example, let's take point M, and we're going to reflect over the line x equals 2, the point negative 1, comma 3. Okay, so let's see here. So let's plot that, and we want to come up with a new coordinate. So negative 1, 3 is the point there. So negative 1, 1, 2, 3. There's point M. And we want to reflect that over the line x equals 2. Now, you may not remember, but in algebra, you guys talked about vertical and horizontal lines and how to graph them. Okay? So, the line x equals 2, let's see, where does x equal 2 on the coordinate plane? Well, here's the x-axis, and here's the point where x equals 2. But x equals 2 all along this vertical line, right? Everywhere, every point along this line has a coordinate of x equal to 2. The y-coordinates change, but the x-coordinate stays the same. So this is like reflecting, and I'm going to temporarily kind of draw this in kind of lightly. I didn't do a great job there, but... Okay, so there's kind of our line of reflection, lightly drawn in. So we want to reflect point M over this line of reflection. We can't use one of our previous rules because it's not reflecting over the x-axis or reflecting over the y-axis, but we can still use the general kind of principle that we need to have M be equidistant from the line of reflection and perpendicular to that line of reflection. The perpendicular distance there. So how far is M from our line of reflection? We'll just count it. 1, 2, 3. So M's got to go in the opposite. M prime's got to go in the opposite direction. 3. 1, 2, 3. So there is M prime. And in fact, I should probably use a red pen here. So 1, 2, 3. 1, 2, 3. Boom. There's M prime. And so that's coordinates 1, 2, 3, 4, 5. 1, 2, 3. So 5, comma 3 is M prime. Okay. All right, let's try another one. Let's do N, and we're going to reflect that over the line y equals negative 3, and we'll give it the coordinates, we'll give the original point the coordinates 4, 0. Okay, and again, we want to come up with N prime. So let's see here. So N has coordinates 4, 0. So 1, 2, 3, 4. And that's N. And we want to reflect that over the line y equals negative 3. So let's see here. 1, 2, 3. So y equals negative 3, okay, is a horizontal line. Again, you just got to, it's because it's easy to forget, right? How we get these mixed up. X equals, is that a horizontal or vertical line? Y equals, is that a horizontal or vertical line? Well, where does y equal negative 3? On the y-axis, there's where y equals negative 3, but it's any point to the left or to the right of that as well. All those points along this horizontal line have a y-coordinate of negative 3. The x-coordinates change, but the y-coordinate are always negative 3. And so we can kind of, again, just for our benefit here, I'm going to go ahead and highlight that using my pencil. Okay, so you can kind of see that. Okay. And so we want to reflect point N over that line of reflection. So again, it's got to be equidistant, right? So it's 1, 2, 3 away, so we'll go down 1, 2, 3, and there's where N prime has to be. Okay, so 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So 4, negative 6 is point N prime. Okay? One more here I want to do, just for some help. Last one, we'll reflect point O over the line y equals negative 5, and O has the coordinates negative 3, negative 5. Okay? So again, I'm going to erase my old line of reflection here, just so it's not going to confuse us. Okay, I'm going to plot point O, which has coordinates -3, -5. So 1, 2, 3, 1, 2, 3, 4, 5. There's O. And then y equals -5. So we just talked about where y's were. Y's are those horizontal lines, and so this horizontal line goes through -5. Okay. Well, now this is interesting. Our line of reflection goes through our point. So how are we supposed to reflect it when our point is on our line of reflection? Where does it end up? Well, follow the general principles that we've been following, right? When we wanted to reflect M, we counted how many units away M was from the line of reflection. It was 3 away, so we counted 3 in the opposite direction. N, we counted how many units it was away from its line of reflection. It was also 3 units above, so we went 3 units below. O is how many units from its line of reflection? 0. So how much do we have to move O to get O prime? We have to move it 0 units. It's the same point. So O prime is the same as O because it's on the line of reflection. Okay, it has nowhere to reflect to because it's on the line of reflection. Okay? So here I'm going to give you guys 2 things to try on your own here. All right, just to see how you do. So I want you to reflect A, B, C, D over the x-axis. Okay, I'm going to go ahead and give you A, B, C, D here, okay? So A has coordinates -3, 4. B has coordinates 0, 6. C has coordinates -2, 1. And D has coordinates 1, 2. And then I also want you to reflect triangle ABC over y equals x. A has coordinates 1, -3. B has coordinates 4, -6. And, oops, I don't need a comma there. And C has coordinates 6, -2. Okay? So go ahead and do that real quick, and if the substitute would go ahead and pause the video, then I will have kind of a prepared, I'll get it graphed and have the answer for you there as well. Okay, so go ahead and give that a shot on your own. Plot the original, and then plot its image over the reflections that I indicated there. So the first one, plot it, and then reflect it over the x-axis. Second one, plot it and reflect it over the line y equals x. Okay, so go ahead and pause the video now. And then I'm going to go ahead and get started on this. So -2, 1 is C, B is 0, 6, 2, 3, 4, 5, 6. There's B. A is -3, 4. And then D is 1, 2. So there's D. Okay, so just as a quick kind of like sketch there. Okay, and reflecting over the x-axis. So again, let's just focus on reflecting the vertices here. So reflect A. A is, let's see, here's the x-axis. A is 4 units above, so we're going to go 4 units below. So 1, 2, 3, 4. There's A prime. C is 1 above, so 1 below. C prime. B is 6 above, so we'll go 1, 2, 3, 4, 5, 6 below. There's B prime. D is 2 above, so 2 below. D prime. And then you can connect the dots. Alternative to this, you could also use your patty paper, okay? You would again kind of like draw the line of reflection, get the points on there, and then flip your paper over and then trace the back to get those. Or you could also use your mirror and reflect onto, you put the mirror on your line of reflection there and reflect the original across. Now, I'm, of course, the way I have it oriented, I'm reflecting the image onto the original, but they should match up too, right? All right, and then last one here, the triangle. A has coordinates 1, -3. So there's A. B has coordinates 4, negative 1, 2, 3, 4, 5, 6. And then C has coordinates 6, 1, 2, 3, 4, 5, 6, negative 2. Okay, and again, I'm just going to freehand this for the sake of time. Okay, like so. And we're going to reflect that over the line y equals x. Okay, now, in this one, I'm a little less sure about what it's going to look like here because, actually, I'm going to use my mirror to get the right things here, get a nice line. I'm a little bit unsure about what this is going to look like. I'm not sure how to eyeball this. I'm less confident in my ability to kind of eyeball the line y equals x. Okay, I can draw it in there. Wow, that is not at all the line y equals x. That's really weird. My graph paper here is kind of funky. So I'm going to have to like... Oh, that's why, because it's not square, Mr. Widmeyer. Okay. There we go. So again, it's kind of like, all right, I can see A. That's pretty easy. It's like 2 diagonal blocks away, so A prime will probably be like right there. Okay, C is 1, 2, 3, 4 diagonal blocks away. So 1, 2, 3, 4 diagonal blocks away there should be C prime. And B is 1, 2, 3, 4, 5 diagonal blocks away. So 1, 2, 3, 4, 5. There's where B prime should be. Okay? But don't forget, if you have trouble eyeballing this, remember we have our rule from the other side of the notes, right? If we want to reflect over the line y equals x, what do we have to do? We just have to take our original xy coordinates and flip them. So, A, which was originally 1, negative 3, oops, you can't see that, sorry, becomes A prime, which is negative 3, comma 1. B, which is originally 4, negative 6, becomes B prime, which is negative 6, comma 4. And C, which is originally 6, negative 2, becomes C prime, which is now negative 2, 6. That's a lot easier than eyeballing it, okay, if you just can remember that rule. So let's just check it. A prime was negative 3, 1. Yep, that's correct. So I can go ahead and color that in. Okay, good. B prime should be negative 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yep, so that one works. And then C prime is negative 2, 1, 2, 3, 4, 5, 6. And perfect. So I did eyeball it correctly. But if you ever have trouble eyeballing it, feel free to go ahead and use your little rule there. Okay? Now, one last thing I want to ask real quick. How do you think the area of this original triangle ABC would compare to the area of triangle A prime, B prime, C prime? Again, remember, a reflection is a rigid motion transformation. So what do you think? How should these two areas compare? Okay? And the answer is they should be congruent. They should be equal, right? If they're the same size and the same shape as one another, then they should definitely have the same area. Okay, at this point, hopefully you don't have any questions, and I will have the substitute pass out the homework, and you guys get to work on that. Please only do the problems on the sheet that are not crossed out. Okay, good luck, and I'll try to answer any questions that you guys might have on Monday. Have a good weekend.